Welcome to my data structure series. This is the continuation video after insertion operations in a doubly linked list. Today we are going to discuss deletion. Like insertion, deletion can happen at the beginning, at the end, as well as in the middle. So I assume that my doubly linked list has nodes 1, 2, and 3. Unlike a singly linked list, we can traverse both in forward as well as in backward direction. Look at the algorithm how to delete at the beginning. If the head is null, display list is empty. Yes, obviously, if the list is empty, you cannot delete. Temp is equal to head. Head points to the first node. Head has the address of the first node. Now temp points to the head, right? Head is equal to head arrow operator next. It means that you make head point to the second node now. So head no more points to the first node, head points to the second node. Heads previous. So this is the head now. So a node has three parts: data, previous, S, and next. Now heads previous is equal to null. So this heads previous is made null and this is freed. Free temp. Temp is pointing to node 1 and this is freed. So this is how you delete at the beginning. Let's understand how to code deletion at the beginning. If head is equal to null, yes, obviously head is equal to null means the list is empty. You cannot delete from an empty list. Yes. Else, what should you do? Temp is equal to head. Assign temp is equal to head. Move the head to the next node. And if head is not equal to null, yes, obviously head will not be equal to null. So heads previous is made null because this is going to be the first node now. And free temp. Temp points to the previous first node which is getting freed, deleted. That's it. Deletion at the beginning is over. Now let's talk about deletion at the end. So now assume that there are nodes 1, 2, and 3. So as we have seen, you can traverse both forward as well as backward, right? So how should you delete at the end? Now make temp point to the head. Okay, so head was pointing to 1 previously. Now temp also points to head. Use temp traverse to the last of the list. So now temp points somewhere here. Yes. So now what you try to do? Temps previous not equal to null. Yes, temps previous is not equal to null. So what you try to do? You try to make temps previous next is equal to null. Okay, so this node has three compartments. So temps previous is this, which points to the next is this. You make that next null. Okay, so else head is equal to null. Else part will not execute here. So this part is over. Now free temp. Temp is pointing to node 3. Free temp means node 3 is deleted. Deletion at the end is also very simple. Let's understand how to code this. Check if head is equal to null. If head is equal to null, list is empty. Else temp is equal to head. Use temp, move to the last node. Temps previous is not equal to null. Check for the condition. Makes temps previous next is equal to null. This means that you are making the node before the last nodes next as null and you free the temp. That's all is deletion at the end. Talking about deletion at a specific position or deletion in the middle of a doubly linked list. So how should you do that? I assume the same example 1, 2, and 3. So I can traverse forward as well as I can traverse backward. Now I should delete. So now head is pointing here. Fine. If position is equal to 1, this means that it is insert in deletion at the beginning. You call the logic for deletion at the beginning. Fine. So run a loop. Find out the position where you have to delete. Say for example, this is the position that you have to delete. If temp is equal to null, it's going to be an invalid position. Now you find out the valid position, execute step number 6 and 7. Look how the pointers are manipulated. Temps previous next is equal to temps to next. So this is made to point 1 is made to point to 3 and temps next previous is equal to temps to previous. That's it. You freed your temp. This is how you delete in the middle or delete in a position. Fine. Let's see how code is being written. You enter the position to delete from the user. Check if head is equal to null. If head is equal to null, list is empty. Else assign temp is equal to head. Check for the position. If position is equal to null, it means use the same logic as deletion at the beginning. If suppose position is not 1 and it's some number, check for the position. Find out the position, use temp to traverse to that position. Yes, if temp is null, then invalid position. Mostly temp will not be null. So execute step number 6 and step number 7 and free temp. So this is how you perform deletion in the middle.